As we explore the beauty and symmetry of group theory, our last video reviewed the order of a group and we defined the order of an element. For the additive group of integers modulo 12, the smallest number of times we add the element 1 is 12 times to get back to the identity. The order of 1 is 12. In this video, we hope to give you an understanding of how sometimes there may be a smaller, easier to study group found within our larger group, something we call a subgroup. The number 1 was a generator of this group because using 1 under our operation of addition, we obtained every other element in the group. It was a cyclic group. But we saw that when we performed the repetitive addition on the element 2, we obtained only the familiar even integers within our group. While the element 2 was not a generator of the group, something a bit more interesting occurred. We obtained a subset of elements, and if we look only at that subset of elements a little closer, we notice that it contains the identity elements, and if we add 2 to any element, we get another element within that group. The same for adding 4 or even 6 or any other element. And that subset is closed under the same binary operation as our original group. We also see that 10 and 2 are inverses, 8 and 4 are inverses, just as 6 again is its own inverse. So all elements have an inverse. And because this is a subset of the original group, we know that the associativity property holds. Remember, it held for any 3 elements in the original group, so this is just a special case of selecting from our new subset. And with that, this set of elements generated by the element 2 hold all of the properties necessary to be a group itself, a group contained within our larger group, something we call a subgroup. For a definition, a non-empty subset of our group is called a subgroup if under the same binary operation, the subset itself forms a group. Now let us see what happens with the element 3. We start with the identity, and then by subsequent addition we get the elements 0, 3, 6, and 9. Again, within this subset we have the identity. We see that adding 3, 6, or 9 would give us another element within the group. This means that we have closure under the original group operation. We also see that 3 and 9 are inverses, as well as 6 again is its own inverse. And again, by definition, associativity holds because this is a subset of our additive group of integers. And so we have another subgroup. We see that the same occurs with the element 4, as we get 0, 4, and 8 as a subgroup. Finally, we can see that using the element 6, we get another subgroup, the identity element and 6. Now there are always 2 other subgroups that we will find in any other group. That is simply the subgroup containing the identity element itself. And remember, the group itself is technically a subgroup. As we are studying the group, creating it as a subgroup does not give us any more information or make things easier. And the subgroup of the identity element alone really does not give us anything useful. These 2 groups are not very interesting, and we call them the trivial subgroups. So let's do away with those and focus on the more interesting subgroups. These 4 subgroups we will call as H, followed by the lowest number that generates the group, H2, H3, H4, and H6. These are all called proper subgroups of our group G. Using our original finite group G, we will highlight the simple but famous theorem discovered by an Italian mathematician named Lagrange. That theorem is, if G is a finite group and H is a subgroup of G, then the order of H divides the order of G. And we can see that in our example by noticing that the order of H2 is 6, and that divides the order of G, which is 12. In this video, we saw that a subgroup is simply a subset of the original elements in the group that still have the basic properties of the group themselves. There is closure under the same binary operation. The associative property holds, all of the elements have an inverse, and there is an identity element. In the next video, we will examine some of the concepts that allow us to compare different groups and their structures. We will see you in that video, and if you like these videos, please give them a thumbs up down below and help the channel grow by telling your friends and becoming a subscriber.